Hi, we are busy doing statistics, and this is another video on histograms for group data with unequal class intervals. This video is simply going to concentrate on how to work with the scales that are given. Okay, in this specific example, they give you the scale for the x-axis where they say 1 centimeter represented by 15 minutes, and your x-axis, which is the time, must be greater than 0 and less than 120. Now this is fairly easy, okay? I'm going to use green again for the x-axis. So on the x-axis, people, if this is your x-axis, this is your y-axis, then remember the origin is your 0. If you have 1 centimeter, so check, find 1 centimeter, then that represents 15 minutes. So my first line is going to be 15. Another 1 centimeter is another 15, so that one is 30. Another 1 centimeter is another 15, so this represents 45. So this is easy because that is just simply how you would do the scale of any x and y axis, okay? That you should be able to do. Then secondly, again, you are given an area scale. Okay, now to be able to draw a histogram, people, you need the x-axis scale as well as the y-axis scale. And in this case, the y-axis scale is not given, but an area scale is given. So from this area scale, our aim is to find the scale for the y-axis. Okay, I always suggest, because it's an area scale, okay, you draw an area. Now in this case, they say 2 square centimeters represent 3 days, which means, people, that I'm going to take my x-axis scale. So my x-axis scale, I'm going to take 1 centimeter. Okay, remember, this is your x-axis scale. I must now draw an area of 2 squared centimeter. Okay, so let's draw the area. Okay, and that part needs to be, that area needs to be 2 squared centimeter. Okay, now you must ask yourself, people, the area for any rectangle is calculated by length times breadth. Okay, your breadth is 1 centimeter. Then how much is your length? So we can just simply write that out as area equals length times breadth. Okay, now look at your breadth. Instead of breadth, you are going to write 1 centimeter. Instead of area, you are going to write 2 squared centimeter. And the length, remember the length, people, that you must now realize is the vertical. That vertical, people, is the y-axis, isn't it? So we are going to calculate the y-axis, which means that you can just simply do Goros o, so take over the 1 there, it becomes divide by 1, which means my length is 2 centimeters. Okay, so this one is 2 centimeters. So divide that into 2 centimeters. All right, so now if you look at this, we have simply calculated the length of the y-axis. It is 2 centimeters. But now we follow the next step. Remember, your scale says that the area is 2 square centimeters, but it is also 3 days. Okay? Now if we go back and we work in the time scale, then we still have area equals length times breadth. Okay? Length times breadth. Which means I'm going to now write that under the y-axis, because remember we're going to get the scale for the y-axis. This is still area equals length, which actually is the y value, times the breadth, which actually is the x value. So now let's work with the time measurement. Okay, look at this one, the x-axis. It is 1 centimeter, okay? But how much time is that 1 centimeter? Go back here. 1 centimeter is represented by 15 minutes, okay? So now here, instead of x or the breadth, we are writing 15 minutes. Okay, the area is 3 days. So instead of area, you are going to write 3 days. And then the length or the scale for the y-axis is the question mark, which we need to calculate. So once again, very easy. We're going to just simply do koros o. Okay, we're going to divide by 15 on this side, and then we get an answer of my length being 0.2. Now comes the big but, and that's always the thing that you must take note of. Let's look at the length. This is the length, okay? We have now calculated this length being 0.2, which is in fact your frequency density, okay? So look at that side. For 2 centimeters, you have 0.2. So on your y-axis, the scale is 2 centimeters representing 0.2. So let's draw a y-axis. I'm going to just draw it in blue because it's all the time blue. This is the x-axis, so this value is 0. Now get 2 centimeters. 2 centimeters. How much is the 2 centimeters? It's 0.2. Okay? Another 2 centimeters. That's another 0.2, which means it's 0.4. Or you can simply now change that to 1 centimeter. So how do we get from 2 to 1 centimeter? We divide by 2. Then you must be fair and you must divide that one also by 2, which gives me 0.1. So on your y-axis, 1 centimeter represents 0.1. The next centimeter also represents 0.1, so you get 0.2. The next centimeter, another 0.1, so that's 0.3. Okay, so all that you need to take note of, okay, is the big part that I said here. Go back to your drawing, people, and there you can very, very clearly see that you calculated with a 2 centimeter length, okay? And for that 2 centimeter length, the frequency density is 0.2, okay? Or from when you have got that written down, you can just simply get it to 1 centimeter, then you can label every centimeter, but then be fair, you must also divide the 0.2 by 2, which gives me 0.1. So, and with this, people, obviously there's your x-axis. That is what you're going to do here. We're going to have 1 centimeter being 15, then 30, then 45, and so forth. And now you've got your x and y axis. And then you can go and you can actually plot your bars. Okay, I hope you understand this. If not, also make sure that you watch my first video, which is also called Histogram for Group Data with Unequal Class Intervals, video 1. Watch that one as well, and I'm sure you will then understand.